In this diagram, we can see our DNA, and on the left we have our exon 1, and next to it is the 5' splice site. So this is the 5' end, and attached to the 5' splice site is what's known as U1 snRNP. In the middle we have our intron, which is of course going to be removed. On the right we see we have our what's known as branch point binding protein, or BBP, and U2AF, which is U2 auxiliary factor. These two bind to the what's known as the branch point. To the right we have our 3' splice site and the exon 2. Okay, and so what's going to happen now is another snRNP known as U2 snRNP is going to recognize BPP and U2AF, replacing them at the branch point. So as you can see, now we have U2 snRNP at the branch point. Okay, so now what's going to happen is what's known as the U4, U6, U5 triple snRNP, and what this reaction is going to do is it's going to sort of like squeeze the introns together and the exons together, of course, and it's going to form this little formation that we see here. And now here in this little diagram we can see we have our U4, U6 snRNP, and I know it's kind of hard to tell, but there's actually a line splitting this snRNP between you have U4 and U6, and down here at the bottom we have our U5 snRNP. Okay, so now what happens is that the branch point will attack the 5' splice junction. This will, through another reactions, cause the U6 to replace the U1 snRNP, as we can see here, and on the outside we have formed our lariat, or our ready to be excised intron. Over here we have our U6 snRNP, and so now the hydroxyl near the U6 snRNP will attack the 3' splicing site, completely excising the lariat, and as we can see here we have our completely excised lariat. Down here we have our portion of our new mRNA, which has been joined. Near the joining site we have our what's known as exon junction complex, or EJC. And now our excised intron will go on to be degraded, and the snRNPs will be recycled and used for other splicing.